So in this video, what we want to look at is what we call factorized by grouping. And so factorized by grouping just needs just a few information to understand it. And then we won't have any problem factorized by grouping. Now, one of the main important idea of factorized by grouping is to rearrange or to arrange the algebraic expression in such a way that you can actually group things, group terms that share what we call common factors. And so if we can do that, then we won't have any problem in factorizing by grouping. Very, very simple concept. So oftentimes when the algebraic expression is written, it is not written in a way that the terms can be easily factorized. And so you will actually rearrange the algebraic expression to have it in that form. And but how do we know when we should do that? Well, if we should actually go ahead and try to factorize this algebraic expression, there will always be two brackets that are identical, and if they are not identical, then something is wrong. And so from there we can actually determine, or we can actually let's say we discern, or to actually realize or pick up that something is not going right with the factorizing. And so let us do an example to see what we're talking about. What we actually do to factorize algebraic expression is what we call the highest common factor. And you would have actually understood, or you would have been exposed to what the highest common factor is in terms of reducing or simplifying a fraction. And so we're going to use the same concept in factorizing algebraic expression by group. And so let's go. If we were to look at this, we can just group these two right here. These are group 1, and I have group 2. So you got, because it's simply factorized by grouping. So what we do, we actually factorize this bracket by the highest common factor. If we should look at 5 and 25, the highest common factor for 5 and 25 is just 5. But we could actually look at the factors of 5. The factors of 5 would be 1, 5. The factors of 25 would actually be, let's say, 1, 5, and 25. I believe there's no other factor. Probably if there's any more factor, the thing is that we want to find a number that they share. They share all the numbers that they share 1, 5, 1, 5. And so the thing is that there's no other factor of 5. So even if 25 has more factor, our main focus here is actually be the 5, because the 5 would be the highest number that this number share. And as well, I want to say share, it is something in common. And so 5 would be the highest common, or the highest common factor, or the highest number that they share as a factor. And so we will pull out 5 outside of the bracket here, because 5 is actually the highest common factor. Now when we look at all the variables that they share in common, well, they just share just m, so you pull m outside. And so after finding the highest common factor, we just create this bracket, because we're going to put the answer in the bracket. We take the highest common factor and we divide it by each term in the bracket. And so we say 5 in itself goes one time. M cancels m, and so we only have n. And if we were to multiply 5m times n, it will actually give us back 5mn. And so you can always use the reverse of the factorization, which is a distributive property, to bring you back to the original state, original state of the problem. And let's look at this one. Oh, this should look like a 5. It looks like a 2. So if I say 5. Now 5 into 25 goes 5 times. M cancels m, and so we don't have anything else to write there. And so that's what we have for that bracket. Let's go to the other bracket. If you should look at, I think I would have left off a number here. I think we should have 15 right here. So it should be 3n to the third plus 15n to the second power. And if we know the factors of 3 and 15, you know that 3 is the highest common factor for 3 and 15. So we pull 3 outside. Now if you look at the variables, this is saying that n raised to the third power, and we have n raised to the second power. When you look at n raised to the third power, it has a n square in it. And so what is really happening is if we say we have an n square and then times by another n, and if we should follow the laws of indices, you know that this will give us, bring back one of the n's or the base term, and we just add the powers. And so since there is actually an n square in this n raised to the third, and we also have an n square here, so the highest common factor in terms of a variable and its exponent would be n square. And so what we would actually do is to take that highest common factor, and we would actually divide it by the terms inside the bracket. And so let's see if we're actually on the right page. So it's a 3 in itself goes that time. That cancels one of the n's in that n and leaves with just one n, plus 3 into 5 goes 15 goes 3 times, no, 5 times, I'm sorry. 3 into 15 goes 5 times. N squared, n cancels n squared. And if you should look at it, you realize that we have 2 identical brackets. And so we could actually prove if we're actually doing anything correctly, or we're actually doing something that has created some error along the way. And so we should always have 2 identical brackets as we go along. And so you can know if the algebraic expression is written or organized in such a way that you can easily factorize by grouping. And so that's just one of the hints you can actually use to see if you're doing the right thing. Just ensure that you have 2 identical brackets at the end of the day when you are grouping by factorizing by grouping. And so when you reach this part, what we do, we group what is outside of the bracket. So we have 5m plus 3n squared, and then we just take any one of the identical brackets. Now, if we were to prove, we could actually use this answer to prove that this is correct. You could actually multiply this bracket, and it brings us back to the original problem. But you can try it in your spare time. So I want you to go ahead and try to do this one as we continue to explore concepts in factorized by grouping. So let's look at this one. So we can actually see what we can see what you can factorize from this expression. So we should group this one and this one and this one and those two. Let's see what all the common factors of 15 and 18, the x and the and so on. So the highest common factor of 15 and 18 would give us 3. Oops, let's see. They also share an x, and so we pull the x outside. So if I say 15 to that goes 5 times, x cancels x, leaves us with w. 3 into this goes 6 times, x cancels x, leaves us with k. And you can actually see that. Let's see what is common in this bracket. Well, 5 is common in the bracket. And what else? Y is common in the bracket. And so if we say 5 into 25 goes 5 times, y cancels y, leaves us with w. And as you can see that you're actually seeing that the variables, the common variables are coming in the brackets. I will say 5 into that goes 6 times, and we say y cancels y, leaving us with k. And when you take a look, you're actually seeing that what is in one bracket is in the other bracket. And so we'll just now group what is outside of the brackets and keep any one of the identical brackets. So we have 3x plus 5y in one bracket times 5w plus 6k. So let's take a look at this one. say we want to factorize this. Let's see if this can just factorize just as how it is written. Let's group these two. What is common in this bracket? Well, the only thing that is common in this bracket is a 1. And any number that you want to use to factorize a term by, if the number is actually 1, it doesn't really make any sense because if we could get him at the same. And so that one doesn't seem as if it could work. This is what's, well, we can only factorize this by b. But factorizing that by b will only end up with this is being the answer. And then we'll actually have like these two here. But do we have anything like what we are supposed to have? Oh, this will be a third power to the third power. But we could actually see that this is not resembling anything that we're supposed to have. And so as you look at it, we know that we should be doing some rearranging. So let's actually group terms that actually share common factors that is greater than 1. And so we could say, okay, let's group 4 to the third plus, let's say, b squared plus 2 plus 8b. And let's see if we could actually factorize these to see if we'll actually get the same answer, the same brackets and so on. So we'll look at this thing, what we could actually factorize is b squared. And so we have what, 4 left. And we just have, not 4 left, let me see. We have now 4b plus 1. If we should factor this, we get what is common in this. We have 2 is common plus 2 is common, and so we have 1 plus 4b. And here, this is basically, they are the same. It is actually in different order, but it's the same thing. It's actually, we could actually rewrite this as this is. We could actually say b to the second, let's say 4b plus 1. And just rewrite this one, just putting the 4 at the front here. And that is basically the same thing. And so we group what is outside. And so we have b squared plus 2, and we take any one of the identical brackets. And so there you go, factorized by grouping. The key thing about factorized by grouping is to group the expression in such a way that you are grouping two, well, at least terms that share common factors. And while factorizing it, when you reach like this part, ensure that you're having 2 identical brackets, and you just take any one of the identical brackets and group what is outside. And always remember, you factorize by using the highest common factor that is in each bracket. So there you go, factorize by grouping.